minus 1/2 log parentheses x squared plus 4 close parentheses.
X squared plus 4 close parentheses. Okay. And the directions, I believe, were to condense. Okay, guys? This is one of the problems from the homework. If you didn't get it done, you need to be writing it down. If you did get it done, you need to have it out.
Well, it's a combined. Yeah, so then.
Okay, and the directions were to condense. Now, first question. Are these logs the same base?
Two of them are. Yeah.
All three of them are. They're all log base 10. Okay? Because you don't see any number anywhere there. So they're all the same base. Next question. Do you have any coefficients?
What about the 1/2 log?
Yes, the 1/2. First thing to condensing is...
And the ones.
And the ones. First thing to condensing is we get rid of all the coefficients that are not 1. So I make this minus log x squared plus 4 raised to the 1/2 power. I reverse my whooshing. Exponents can be whooshed up and down with a logarithm. Yes?
Would by any chance the log x minus 2 plus the log x plus 2 become x squared? Or no, become
Close.
you just put the minus together, right?
Well, what happens is you can find them together by multiplying. That's the key. So because you have addition between logarithms of the same base, that becomes...
Oh, log x squared
that becomes multiplication between what you're taking the logarithm of. So there will be an x squared involved, Saul, but you got to FOIL those first to find it, or remember a certain multiplying pattern.
So it's log x squared minus 4 minus log x squared plus 4 in the half?
Close. Now what can we do? Well, this becomes x minus 2 times x plus 2 is difference of squared. As Sam just realized, it's x squared minus 4. And now that's minus log x squared plus 4 to the 1/2.
log of the 1/2.
Pardon?
So log of the 1/2.
Nope.
Log x squared to the 1/2.
Maybe log.
Can't simplify that further, but there is one, because these are still log base 10.
You can put them over. Log base 10 x squared minus 4 over log base 10 x squared plus 4 to the half.
Correct.
And do you not want exponents in your denominator?
Doesn't matter in this case. So I'll tell you about that in a sec. Because we had subtraction between logarithms of the same base, that becomes division. And if you were seeing this on some multiple choice test somewhere in your future, just so you know, another way to write this is x squared minus 4, I'm going to leave that parentheses there, over the square root of x squared plus 4, because that's the same thing as to the 1/2. Sam was just asking about rationalizing the denominator, how you don't normally want radicals in your denominator. You guys remember with numbers, you multiply top and bottom by a square root to get rid of it. Not so much a worry with the variable, because there are values we could put in for x that might make this bottom rational.
X plus 2.
No, I mean like if x were, I'm trying to give a decent example.
Why don't you have it just x plus 2?
Yeah, why is it x plus 2?
Oh, that's what you're asking.
Oh no, because you're adding.
The addition messes that up. That's one of my pet peeves I mentioned earlier in the year. If I see this on a test, I threatened I will give no partial credit. That does not equal anything at all. Because if these two things are equal,
Yeah, I know.
then these two things would have to be equal. I'd have to be able to square both sides, correct?
Yeah, which is not.
Which is not true, because this would be x squared plus 4, and after I was done foiling, this would be x squared plus 4x plus 4, and they are not equal. So since these are not equal, their square roots cannot be equal. So there.
Why is 1/2 square root?
Because it's a fractional exponent.
It's the same thing as 2. Like it's 2 root of x squared plus 4 to the 1.
So why don't you?
Remember, Saul, 5 to the 1/2 means square root of 5. 5 to the 1/3 means cube root
Oh,
of
wait.
5.
Oh, I see. Because it's square that you don't have to put right the 2. That's all I'm wondering.
Yeah.
Okay.
That part. So this would be the simplest form of the answer. This would be perfectly acceptable as well. This would get you partial credit but not full credit. You got to finish the condensing. A great trick question would be to put a different base here. Because if I made this log base 2 or something, then you cannot do that. These rules only work with logarithms of the same base.
Like number 38.
Does number 38 do that? I'd have to see it. What's it say?
That looks like base 5 and base 9.
It does. I actually believe that's a typo. I believe that it's meant to be log base 5 in both cases. Isn't that annoying? Yeah, 38's a fun one. The print's bad, but if we look at number 38, it says log base 5 of 250 minus log base 5 of 2. Since they're the same base, what can I change this to?
Log base 5 of 250 over log base 5.
Log base 5 of 250 divided by 2. Matt just pointed out that's division. 250 divided by 2 is 125. And now ask yourself, 5 to what power gets you 125?
3.
3. So that's a fair non-calculator question. Even though I don't know without a calculator 5 to what power is 250, and I definitely don't know without a calculator 5 to what power is 2, but because I remember this trick, I can turn it to 125, and without a calculator, tell you the answer is 3.
Wouldn't it be like
Wait, how do you get
5
125?
power equals 250 is like 3 point?
Oh, you divide by
Something. Oh yeah, I get the 125, Eli, because when you're subtracting between logarithms of the same base,
divide them,
make a division.
and what is okay.
And then you do just kind of have to know 5 cubed is 125.
Yeah, I can do that.
But if it's a non-calculator part of the test and you get it to this point, that's where I would start guessing and checking. 5 first is 5, 625. That's where I start losing it.
3,100.
Nicely done, sir. Okay, so that's a fair non-calculator question. This is obviously a fair non-calculator question because you're not being asked to actually solve for anything or calculate anything. New stuff. New stuff, very small new stuff. And it is, again, something we did briefly last year. Briefly, my memory is, you guys were terrible at it, so. No, you weren't. You guys were good at this. You guys were terrible at something else.
This is relevant.
Yes.
That same friend of mine, he one time was hunting for a bear, and he shot the bear's head off.
Saul, I'm recording this, and I really don't want to edit it that closely. So let me just say thank you for sharing, by which I mean be quiet. Okay, this was chapter...
How loud of a noise can you get like
How loud of a noise? Very loud. Do you mean how quiet?
Yeah.
I'm actually not sure. Surprisingly.
Like.
I don't know. Watch it tonight and tell me.
I will not.
All right.
No, you shouldn't edit the stuff out of that, because that's my fault, and I will take responsibility for it, not you.
I do appreciate
The
that.
dumb stuff that I said someone else says is because that person's being dumb, and if it gets caught on film, and someone sees it,
It's
and
edited all
gets
the
mad
time.
about it, and I'll get in trouble, not you.
I'm not just getting mad about it. I just would like,
He's the one who uploads it, so we should
That'd be great impression on this.
It's bad. I mean, I just don't want to give you multiple chances to distract people from this lesson is one thing.
Because you're teaching him talking about stuff.
That's right. Yeah, it's a little distracting, won't lie. Okay, some of these will be best done with a calculator. How far am I going to go with this?
all the way.
Thanks. Yeah, these will be, okay. Well, it's going to, okay, I see what it is. All right. Solving logarithmic and exponential equations. It was.
And in the.
Thank you for money.
Yes. Solving logarithmic and exponential equations. They fall into two broad categories, like just about everything else we're doing here. Fair task without a calculator and where you would need a calculator. Under the fair without